We have to prove this one using mathematical induction. So as the first step, I will try proving it for n is equal to 1. We have to prove for n is greater than 1, for all n greater than is equal to 1. So the first natural number is n is equal to 1. So I will try proving that. So left hand side becomes 1 over 2 to the power 1 minus 1, which is 1 over 2 to the power 0 1, so that's 1. And right hand side becomes 2 1 minus 2 to the power 1, which is 1 minus half, that is 2 into half, that is 1. So that's proved. Now let's assume for n is equal to k, when k is any number, left hand side is equal to right hand side. So 1 plus half plus 1/4 plus up to 1 2 to the power k minus 1 is equal to 2 1 minus 1 to the power k. That we have assumed, and then using this we will try to show that for n is equal to k plus 1, the left hand side is equal to right hand side. If we can do that, we will have proved that the left hand side is equal to right hand side, true for all n is greater than equals to 1. So for n is equal to k plus 1, left hand side becomes 1 plus half plus 1/4 plus up to 1 to the power 2k minus 1 plus 1 to the power 2k plus 1 minus 1. So 1 plus half plus 1/4 plus some few more terms, and then minus 1 plus 2 to the power k, because k plus 1, n is equal to k plus 1, so k plus 1 minus 1 becomes just k. Now this part is actually the right hand side here, because that's what we have assumed. So it becomes 2 1 minus 1 over 2k, and plus here this one is just 1 over 2 to the power k. So it's 2 here, minus 2 2 to the power k plus 1 to the power k. So it's 2 here minus 1 2 to the power k. So this one is the left hand side. Now let's see what the right hand side becomes when n is equal to k plus 1. So right hand side becomes 2 to the power 1 minus 1 over 2 k plus 1, like that. This is the right hand side for when n is equal to k plus 1. So that's 2 1 minus 2 to the power k times 2 we can write, and 1 here. So if we get rid of the bracket, it becomes 2 minus 1 over 2 to the power k, because these 2 and these 2 they get cancelled. So this one is actually the left hand side. So we have done that. We have proved left hand side is equal to right hand side for n is equal to 1. Then we have proved that we have assumed that the relationship is true for n is equal to k when k is any natural number. And then using that assumption, we have proved that for n is equal to k plus 1, that is for the next natural number, if the relationship is true for any natural number, it is true for the next natural number. So when k is any other, like when k is 1, it is true for 2. When k is 2, already proved, it is true for 3, and so on. And this is the way of to prove using mathematical induction. So